Do example 7 and 8 with you guys from the notes. And I'm sure quite a few of you have already looked them up and tried to figure them out on your own, and that's okay. But I also wanted to be able to be the one to explain them to you. I'm picking 7 over 6, mainly because 7 has the similar triangles built into it. That's basically what makes a more difficult related rate question is the similar triangles involve substitution. So let's start by kind of drawing it. Inverted cone leaking water, all right. So I'm just going to draw a two-dimensional view of it. Says the cone has a height of 9 centimeters and a diameter of 6 centimeters. Okay. Oh, diameter. Find the rate at which the water level is dropping when the height is 3. Again, there's two approaches we can take to do this one. My guess is some of you immediately wrote this formula out and then took the derivative of it. Now there's nothing wrong with doing that. So if you took the derivative right away, basically you'd have to substitute later than earlier. And some of you might even found that out along the way or something like that. So if I write out what information I have, it says cone is leaking water at a rate of 1 cubic centimeter per minute. So I have dV dt is -1. The cone having a height of 9 and diameter of 6 aren't actually supposed to really be used at all in the problem. The 9 and the 6 being given to us is just telling us how big the shape is. That helps us solve other stuff. When it says find the rate at which the water level is dropping when height is 3, it didn't tell us a radius. And when it says find the rate, that's telling us that we're trying to find dHdt. And out of this information that we have, absolutely nothing is related to the radius. So that's kind of where the difficulty comes in. If you wanted to do the derivative, did some of you try to do this problem on your own, or did a lot of you just basically look straight at the example and the key and then try to go from that? Do most of you just look at the answer key and try to figure it out? Okay. It's not a terrible way to do it. But the downside of doing that is it makes you think that there's only one way to do the problem, and there's not. So if I would take the derivative right away, this is kind of where you should find out that things don't work as nice as what you're needing them to be. So I do product rule in R squared H. And then when I'm looking at that, I realize that there's a ton of variables that I have to fill in, and I don't have the information for. So I'm going to need to do substitution somewhere. If I decide to do substitution here, I can. The 9 and the 6 at the beginning is only there to tell us how to do the substitution. So it's telling us that the height is 3 times the radius, because you've got the 3 and the 9. Now, if you want to set up a proportion, you still get the same thing. I got quite a few questions that I was asked about the shadow problem. Like, a lot of people were trying to figure out where on earth I can't remember the numbers off the top of my head, but they were very confused by the x plus y over x. And that all came from just setting up a proportion for similar triangles, things like that. If I have 3r is h, in the one in the answer key, they used this information to substitute out the radius. Like, they just got rid of the radius completely. Instead of writing radius in the original problem, they solved it for r and then put 1/3 h in place of r. And then that made only one variable, which made the derivative a lot easier. And that's definitely the way you want to do it. I'm just trying to show you that you can do it both ways. So let's say we try to fill in this stuff. dv dt is -1. R, we don't know. But we do know that h was supposed to be 3. So if h was 3, then r is 1. dh dt is what we're trying to solve for. R was 1. dr dt, again, we don't have. But if we take this equation, if we take the 3r equals h equation and take the derivative of that, the derivative of both sides would be 3 times dr dt equals dh dt. And so we don't know the number to put in place of dr dt, but we can substitute 1/3 dh dt for it. And then the height was 3. This one, the method isn't impossible. You're just doing substitution a lot along the way. Now, 100%, I'd recommend you not do this method, right? Like, this is a lot more work. I'm assuming that you guys already have the other method written down because you looked at the answer key. So that's why I wanted to put this one up first. If you can do substitution, you want to do it before you do the derivative, right? I'm just trying to show you that both ways work. Because a lot of times what happens is you guys will be taking the test and you're all stressed out. And then you'll take the derivative without even looking to see if something can be substituted. I'm just trying to show you that it will work. You don't want to do that because it's way more math.
I'm still confused. Why can't she plug in 3/4h before you do the derivative?
So, like that number?
Yeah.
The reason you can't plug that one in is because that's at a certain moment in time. Do you remember the ladder problem? Like, there was a ladder leaning up against the house. We were able to plug the 25 in for the ladder because that ladder never changed size. It wasn't variable. The height of the water does change throughout the problem. The height of the water isn't 3 for the entirety of the whole thing. So you can only plug in the 3 after the derivative, because the derivative is kind of looking at a certain moment of time.
So I can only plug in like constant numbers?
Yes. Yep. Okay, so I'm gonna substitute out the radius first. And I'm gonna get 1/3 pi, 1/3 h, squared h. So the volume is gonna be what, 1/27 pi? H cubed? And then this derivative is a million times easier. So dv dt is gonna be 3 pi 27ths, so pi ninths. H squared dh dt. And then this one, we're trying to find dh dt, but we have a number to put in place of h, and we have a number to put in place of dv dt. Substitution, if you need to use it, you're gonna wanna do it before you do the derivative. So I guess what I should have stated clear at the beginning, it's important for you guys to write out what information you know and what information you're trying to find at the very beginning of the problem. Because it tells you what information is missing and or if you're gonna run into a problem. Like if you're gonna run into an issue. As soon as I wrote out all of my info that we were given, I saw that I only had things for height. I had nothing for the radius. So I kind of knew that that was gonna be an issue going forward. And then that would tell me to substitute out the radius. Does that kind of help a little bit? I mean, I'm sure a lot of you looked at the way the problem was already done in the answer key and maybe you figured it out from that. But it's, like I tried to write on the test outline, it's not gonna happen every time. It only happens when you are just not given enough information. And it can only work when you're given a problem that has like proportional information. Like this one, when the water's leaking out of the cone, this triangle is a similar triangle to the big shape. And that's the only reason that method works. And that's gonna be the exact same thing on the shadow problem on the next page. Both of them were set up pretty similar. On the shadow problem, they told you how tall the lamppost was, how tall this person was. And then it said, what did it say? Walking away from the lamp at a rate of 4 feet per second. So whatever variable you call this, it's telling us that this is changing at 4. And then it says, when he is 20 feet away from the lamppost, find the following. How fast is the length of his shadow changing? Well, the length of his shadow is a different variable because we weren't told it. And then that means we're trying to find dy dt. And this one's just, this one, I guess we're not really doing substitution on this one. This one's just set up as it's shown to as similar triangles. So the man with his shadow is going to be a proportional similar triangle to the entire thing. And I know in the answer key, it doesn't explain where that first equation comes from. I believe it just writes the information down right here, and then it does the derivative. Because the big triangle is the same shape as the little triangle, then you can make them proportional. So the lamp post is the same as the person. And then the entire bottom is proportional to the little bottom. And it doesn't even have to be this order or direction. You can write 26 over 6. You can write x plus y over x. But from this step, they just cross multiply. And then did the derivative from there. And then this is where I mainly got questions from some students, is that, like, they had no idea how you went from here to here. And I'm sure some of you might have recognized it and remembered cross multiplying. I don't know. I haven't even had a chance to really talk to you. Do these types of problems, did they feel difficult when you were working on them in the homework? Is it because little bits were changing on them? Or?
So that's not gonna be on the test, because that's not like substitution, like that's not gonna be like a shadow problem's not gonna.
I definitely shouldn't say.
Okay.
Do you hate the shadow ones or something?
No, you just like, it's said on the.
Well, you're
outline,
correct, it's not actually substitution.
Okay.
That's all I should say on it, yeah. I was thinking this was gonna be substitution because it was similar triangles, but there isn't really any substitution in it. It's just kind of a strange setup. What I dislike about the shadow problems is the length of the shadow changing is completely different than the tip of the shadow changing. Like if you guys looked at problem B, these were basically completely different types of problems, even though it sounds like the same thing. So I'm just gonna ignore B for now. I'd rather focus on A because that's more the style that you'd have to do. I don't know, is there something you guys want me to help go over from the homework, or is there anything that you want me to help answer for the test tomorrow?
So, no angle problems. And
There won't be an angle problem. I never had a chance to go over one, and it's okay.
And will you give us the base formulas for like the cylinder, the cone, test?
I mean, so you're supposed to know all the basic shapes: circle, triangle, rectangle, square. The areas, so the two-dimensional versions, but you should also know the three-dimensional versions. So like prisms, or like a sphere. Cone is kind of a in-between one. I don't know. I mean, like, I feel like you've done the same formulas enough, you probably semi-know them already. No? How come?
I know everything's a cone, so.
If it's not a normal, regular shape, definitely will be given to you. Like I know on the past AP test, they did one with the area of a hexagon, that was given to you, because you're not going to be expected to know. But regular shapes, you're generally expected to know.
So I'm gonna have to be expected to know cone and cylinder and point.
Cylinder, definitely, that's just a circle times depth. Every prism, should I quickly review that?
Yes. Yes.
Really? You guys forgot all the prism stuff?
Yes. Wait, isn't it just length times height?
Kind of.
That's
Okay, let's talk about how bad that picture looks. So, this is a circular prism. A prism just means that the shapes on each end are the same, and then they're connected by depth. So, a triangular prism would be like a tent. Every single prism is going to be the area of the end piece times the depth. So like this one, you find the area of the triangle multiplied by the depth. So I guess there's only three prisms you're supposed to know: cylinder, tent, and box, which I hope you know box, I know. I mean, I guess the easiest answer is, we haven't written the test yet, so I don't know which formula I'm gonna need to give you or not. Yeah, it doesn't, it's right. That's why I made up an outline, so you know what would be on it. we already kind of know how we wanna set it up. We just can't reuse tests from year to year. 7, that was what the outline was.
Oh, so it's the exact number, oh.
Yeah, the
I
outline was
didn't
telling
get
you, the outline was telling you that question number 1 is converting from sentence, it's posted in the folder, Schoology folder. That's gonna be a terrible picture.
that. No, I got it.
All right.
It's up our computer.
Oh,
Yeah.
okay.
No,
These are gonna be the 7 questions. That's traditionally how I write out the outlines, is I'll tell you exactly how many and what type, where they're from. These should go extremely fast, so you basically have 5 questions to do over the whole hour. And I also didn't wanna give it on a Wednesday, because you'd have 9 minutes less time. Oh, no, I didn't last time either. Mr. Stouffer usually puts together like the little quizzes. But I don't like doing those because it kind of makes people feel like academic test questions. Okay,